Here's everything you need to know about the compilation process of C programs using GCC. Let's start with the basics. C is a programming language. C files usually end with a .c file extension. C files are human readable and written in plain text using alphanumeric and math symbols. This makes C a high-level language. Yes, high-level. Here's why. High-level languages are user-friendly and abstract from low-level computer processor operations. Low-level languages, on the other hand, are more machine-specific, like machine code, which is written in binary, ones and zeros, or assembly code. With this knowledge, it is therefore necessary to convert C programs to a language that computer hardware can understand. Compilers convert code from their source language, in this case C, to the target language, like machine code. Here's a basic structure to compile a C program in Linux using GCC. The compilation process involves the following steps: preprocessing, compilation, assembly, and linking. To illustrate the compilation process, let's create a simple C program. Following tradition, we must create a hello world program. Here's the code that goes into the program. To compile the main.c file we just created, run the following command. This will create an executable file called a.out. To run the a.out executable, run the following command. We just made a C program. Pro tip: this is time for you to include this in your resume. You're a C programmer now. The compilation process we just saw just went through a couple of steps. Do you remember them? I mentioned them earlier. That's preprocessing, compiling, assembly, and linking. Let's go through this one at a time. In the preprocessing step, the preprocessor removes all the comments from the main.c file, searches for and includes code from the files referred to in the include statements, replaces the content of tokens defined in the defined statements. To generate preprocessor files, run the following command in your Linux terminal. In the compile step, the output file from the previous step is converted to assembly code. The resulting file from this step has a .s file extension. Please note, this is the step that generates assembly code and not the assemble step. To generate assembly code, run the following command. In the assemble step, the assembly code generated in the previous step is now converted to machine code. The machine code is an object file and has a .o extension. To generate machine code, run the following command. And finally, the linking step. This is the final step of the process, and the process links all the files from all the previous steps together into one. This is the process that generates the executable. And that's it. That's the compilation process of C programs using GCC. I hope you learned something new, or at least refreshed your memory on this very beautiful process. Thank you for watching. If you loved this video, please like and subscribe.